So this is not a word description. This is set border notation because of the definition here. Are you okay? So when definition is not there, then it goes back to what word description form. So kill, set kill is defined as, so X is defined as, X is a vowel of English alphabet. You know the kind of, the group of X, where X is coming from. We have different forms of languages alphabets. So we need to specify English alphabet. Let's look at the last one. Set R. So now, as we have been able to learn how to read this, one of you should read this for me correctly. The third one. Change it to our normal English language. Yes. Okay, then I'll point. Should I point? Yes. Okay. Brother, transform this into our normal language, English language. This is mathematical language, so change it to our English language. Read it for us to understand. Amplify your voice, please.
X says that X is greater than 1 and X and 12 is greater than X, where X is a prime number.
Thank you. But in the form of the reading, all must talk about X. So you take X, you start from the X to the right, to the left. You have to take the same X to the what? Right. So what I saw here is, you said X is, what you said is correct too, but the reading should always talk about X. So X is greater than 1 because it's open to the X. X is greater than 1. And what? Oh, but less than what? 12. But you made it X is greater than 1, but 12 is greater than X. Understand? It is also correct. That's how you understand it. You read according to how you what understand. But the normal way of reading should be X is greater than 1, but X is what? Less than what? 12. Are you okay? Yes. And the region where X belongs is defined here. X, where X is a prime number. If you did not say this attached to the set defined here, then you are being open to write any number of your choice, whether any form of real numbers, whether rational numbers, irrational, and this can be irrational. So it can be in the form of whole numbers, it can be in the form of natural numbers, but they are restricting you on where X belongs, prime numbers. So when you are stating 8 members, you should be able to state the range given to you. You pick all the prime numbers from it, and that will be your element within the set. Are you okay?
Yes.
Do you understand what we are doing?
Yes.
Okay. So we are just looking at how we can present it. But when they give the expression to you in the number 2, word description, and in number 3, set border notation, it is compulsory for you to write them in number 1, listing the members. So when it's given to you in number 2, in number 3 forms, you have to write them in the form of what? Listing the specific members contained in the set. Then you do whatever the question also will ask you. Let's also look at types of set that we have. Types of set. Just discuss the types of set and know how to use them fast. So we have, quickly, just give me the types of set. Yes, any types of sets. In which form a set can be presented? In which form? Types. A unit set. So if you give me that type of sets, give me a brief explanation on it. Second explanation, some seconds. So stand up and
The type of set that has only one element.
good. I hope you heard him. So he's saying a unit set. So he said one type of set is a unit set, and he explained it as what? A type of set which has only, that's the key word though, which has only one what? Member contained in the set. Only one member. Can be of any form. Please analyze this for me. I have set A equal to, so this defined set here, does it have a member? Oh, why? Is that it has a member? Why is a member? But 0 is nothing. It is a number. It's a whole number. It's part of what? A whole number. So 0 being written in a set alone is a member of a set. So most ideas concerning zeros, they think that 0 is always what? Nothing. So when you define a set and we only write 0, most people present 0 as a null set. Okay, so since something has been written in the set, then the set has a member. Are you okay? Yes. All right, so we have a unit set now. Let's move on to other types. Quickly, finite set. Don't sit down. Explain to us. Okay, he's saying that finite set is a set which the last member can be found or be determined. All right. So, who gave me the finite set? Come and give me one example of a finite set on the board for me. Thank you. Good. Now, the idea to what she came to present to us here is that the last number is found. Truly, can you see the last number in the set? So she has defined a set for us. So since the keyword means the last number should be found, that means the set is finite. So that is the meaning to the definition of finite set. Yeah, it's fast. Different types of sets. Infinite sets. What is it?
Its last member.
So it is opposite of finite, right? So infinite, its last member cannot be found. And what do we use to represent that unknown last number? Come and help us. Come and write it here. Use this space. Use this space. Yes, just define a set for us. So how will you determine the last number hasn't appeared? So what expression or symbol is being noted for that one. All right, so thank you. Thank you. So with this expression, you can see that in a defined set, the last member in the set is not there, right? And you always see this three dots there. That tells you it continues. So someone will ask, what if it is 4 dots or 2 dots or 5 dots? You don't just be putting down any dots. The number of dots that you want. When you are tired and you stop. It's supposed to be only what? 3. Are you okay? You can't put 2 there, you can't put 4 there. So is somebody saying why? It is a form of expression being represented for a finite set and in the mathematical language. Do you get it? So that is it. Then which one again? Fast. Noun set. This one, I hope you all understand now. Another name to represent now is empty. Empty. What is a symbol for empty? In mathematics, so not in English that come and draw a bucket and leave nothing inside and say, hey, the bucket is empty. No. In mathematics, what is the symbol for empty? Empty. Empty. I just need a symbol. Empty. Who is ready? I just need a symbol on the board. Empty sets. You know, empty can be represented as the bracket without nothing inside, but I want the symbol. Okay. Don't give me any set notation. Just come and draw the symbol for me. Hurry up. Good. So we have this symbol representing what? Empty, right? So a null set or empty set, and it can represent by this symbol. So we can talk about universal set, equivalent set, equal set. Okay? Universal set, equivalent set, equal set, or any form of other set that you have not mentioned, since it is a well-defined or it forms part of the set category. Okay. You have 3 minutes to list the members of this given set for me. Your time starts immediately I stop writing, so you can write the question. Your time starts now. 3 minutes. So I'll sample 12 you to come and present your answers on the board. So make sure you write the answers. So you don't know whom I'm going to call. So make sure you write the answers. Stop work. Now, I'll not ask you to be ready. Raise your hand before. Since all of you have worked, let me give the marker out to anyone I want. Okay, take this. So take the middle board, which means you are doing the first one. Do the second one at the other side at the same time. No, the second one is not for you. Do the last bracket or the carry bracket. Use the marker. Thank you. Thank you. Please let us analyze the answers that they have given to us and see whether all the members has been listed. Okay, so for number 1, we have a set defined set P. X is a multiple of 3 less than 18. So this, you need to know multiples of numbers, especially 3. Then be able to select the range where the counting of multiples of 3 will end before 18, right? So we have here to be 3, 6, 9, 12, and 15. Since she did not include the last number 18 because of the restriction given less than. That makes
Hi, Mr. Abuaje George.
valid.
How are you doing?
Correct.
Hope you're good. So your question.
Are you okay?
What is he doing?
The second one, we have
Actually,
the instruction
he
here.
is
X is greater than or equal to 3, but less
he's
than or
doing
equal
40
to
hours
12.
mathematics
because of the
teaching
or
mathematics,
equal to
and
symbols attached to the
he's trying to break
it
Guinness
means
Book of
the
Record.
first number
So that's
and
what
the
is
last
happening.
number
And the name of the school
should
is
form part of the
Agri
set.
Memorial.
Let's see what that is
It's
there.
happening live in Cape Coast.
So first of all, I'm just
Agri
inspecting the
Memorial.
first and the last number before I
So
look
it's
at the
a
ranges,
Guinness
the
Book of
numbers in
Record
between.
challenge.
So my
And he's
first
doing
number is
40 hours
Surely,
teaching
it is
mathematics lessons.
there.
As you
Then
can see,
12.
these students
Okay,
are
it
from
is also
Agri
there.
Memorial,
Let's look at the
located
thing
at Cape
between
Coast. I'm live there.
members.
Yeah,
So we
so
have,
you guys should share this
and
live.
S should be what?
Share the
An
live so more
integer.
people can
So
see
just
what is happening. Okay.
continuous counting.
I hope you
right?
enjoyed.
So we
Bye.
have 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This one too makes the set defined. When mistakenly you change the notation, then it is not defined. As they have restricted you on the notation you are supposed to use, that is what you should always use. Let's continue. We are going to talk about Venn diagrams. Venn diagrams. Venn diagrams. You know, we can present sets in different ways. Not describing set that we talked about to present sets in different ways. In different ways. And in this form of ways that we can present sets is what we call it Venn diagrams. Using diagram to represent sets outside the defined bracket that we have been using. So I can have this set. Then we have been asked to define or represent this set in different ways. So we can first represent this set in the form of what? In the form of what? In the form of what is the symbol over there? Circle. We can also present this set in the form of what is this symbol? Square. Or any other form. Yes. So the Venn diagram does not restrict us on a specific diagram to be used. We can represent sets in different forms of diagrams. So I can present this set here 1, 2, 3, 4 inside my diagram. Then over here to 1, 2, 3, 4. Over here to 1, 2, 3, 4. Anywhere you write inside any area being occupied in that particular diagram is acceptable, since the member can be found within the set. So this is the various ways to present the Venn diagram. But we're going to stick to one of it, using circles to present Venn diagram. So we're going to look at how we can present Venn diagram. We are going to start with two-set problem. Two-set problem. This is when two different sets has been given to you to state its properties or common features or talk about them. When two given sets is being presented to you, that is the two-set problem. All right. So let's look at how we can present this in a defined diagram and know the meanings of the regions in the diagram. So we have here to be so this is the Venn diagram we are using to present our two given sets. So we don't have any defined sets here, so we are going to just label the Venn diagram. So when a question is being given, they will use the information of the question to fill everything. So over here, my first, you see, I'm giving you that one given figure or shape presents a given set. So we can say I have two given what? Circles being drawn inside our rectangle. So each of the diagram here presents a set. So this is set A and this is set B. And what we have in the rectangle contains everything that is contained in the both sets, set A and set B. So we label this as our universal collection of the two sets. Now, let's look at the regions where these two sets have in terms of their properties. So we have here to be. So look at this. We have the first set or the second set, they overlap each other, right? That means surely these two sets have something in common. So you start numbering the region from their common properties before you look at their differences. Are you okay? So our number will start from what they have in common, the common properties. Then we come to our region 2, region 3, and since these two circles are being contained in the rectangle, we have areas around the rectangle that hasn't been occupied. That tells us something, that there are some elements defined in a bigger set that does not belong to any of set A and set B. So you also label that part as region 4. Do you get it? Now let's further explain the regions over here. So we have region. So let my R represent region. So region 1, region 2, region 3. So for region 1, it contains elements that are found in the two sets. So we have both sets A and sets B. So let me shorten this so that I can write the expression for A. So we have both A and B. And can also be written as in the form of cardinality. Okay. So we have so A intersection B. So it is number of A intersection B that is being contained, but let's make it A intersection B for now. So we have this as A intersection B. That explains both A and B. They have something in common. So region 2, can see that this region, this diagram representing set A is being taken from this direction. Look at this. From this bigger circle. Okay, this one is clear. This is the diagram for region A. But since region B is taking part of region A, we are supposed to cut off that common part that region B has covered from it. So we have here to be so look at the direction of the red marker. So we have taken off region 1 from region 2. So that tells you that whatever that is contained in region 2 talks about only aspect or only members being contained in A, which means they cannot be seen in B at the same time. So you can write this as only sets A. Only sets A. So the word only is very, very important. If you just write set A, you are talking about a bigger set. But if you say only set A, that means the common element that B also have has been taken out. Then the difference becomes the only part of the set A. So we have here to be, and we can also write this in the expression. So we know we have A, since they overlap each other, we write it in the form of the intersection A A intersection B. Now we need to make difference because we are taking B out from what? A. So apply the symbol to the one we are taking out. So apply this symbol to B. And that tells you, so this symbol talks about not. Does not belong. So B is being taken out. All the elements contained in B are out from A. So this represents A only. So you can see the bigger portion of B. 1 and 3 are all for B. So they are being taken out and only 2 is representing for A. That is the expression for only. We can do the same thing for B. Write the same expression. B also talk about only set B. And you can write A intersection B again and express a symbol to A, that is the complement symbol. That gives you the definition to be A prime intersection B. So we are talking about only set B. Let's take an example to explain, and it's left with region 4. Let's talk about region 4. So region 4 talks about neither A nor B. So does not belong in A, at the same time does not belong in what? B, set A and set B. So neither. And it is that symbol that we represent as a complement. Okay? So that symbol that we represent as complements. So A intersection B or complements. So let's take an example. Okay, so before we look at illustrations explaining the Venn diagram, let's quickly look at some of these concepts, subsets.
But Joe's gone. I don't know how to pronounce your name though. So we are here, and the challenge continues. Yeah, thank you so much. Thank you so much for your prayers. We need your prayers. May God strengthen him so he can, stand to finish what he has started, okay? For those of you that don't know, this our Ghanaian brother, he is going on a challenge, Guinness Book of Record challenge, teaching mathematics lesson for 40 hours. As you can see from your screen, we've done just 1 hour, 16 minutes, and God,
Okay,
we
so
still have a long way, but we hope and pray that
we also
things
have
will
a
go
symbol
well.
to represent subsets.
Thank you so much for joining. Share the
Okay.
video to whoever you think
That is the
need to see this, okay?
elongated C.
I love y'all. Your girl is behind the camera, bro,
Okay,
sis.
call
Take care.
it elongated C. It's not C, it's a symbol. So elongated C. So use this to represent subsets. And subsets are sets being derived from the mother set, or a bigger set being defined, or from the universal set. So let's have a given set. So set A can be a universal set. That is 1, 2, 3, and 4. So we are considering our bigger or mother set to be set A. Then any other set that we can derive from set A, if and only if the elements of that given set you are deriving are all in set A, then that given set you are deriving are known as subsets of the mother set A. So if you tend to represent different sets out of this, and you include 5 or 0, which are not part of the defined mother set, then that new set you are writing is talking about something different. Let's see how we can derive different forms of sets from this mother set A. So if a given set like this has been given to you and they ask you to list all the possible subsets from this given set, you always have to start from 0. Start from the null set or empty set. So you are going to list all the subsets. So let's look at this. Starting with empty brackets, talks about the null set. Then we are looking at how we can derive all forms of sets from any given set. So you are starting from the small form of set to the bigger set. So start from the null set. Then after that, you go to what? Unit set. You go to unit set. So we have here to be the unit set that you can get from this are the individual members representing themselves as a set. So we have here to be 1 alone being defined as a set by itself. Then we have 2, 3, and 4. So after you list all the possible unit sets, now combine them in 2s. Make sure your pairing is accurate. All the possible pairing that you need to give to each other are being presented. If not, we will not be able to get the quantity of subsets you need to get out of that given set. We are looking at all the possible subsets that we can get from set A. We shouldn't even leave one out. We are listing everything. If they have asked you to list only 5 subsets from set A, that one, after you have listed 1, 2, 3, 4, 5, we are done. But I said all the possible subsets, we have to list the last set. So combine these two elements. Now we have the null set. All unit set has been written. Now let's combine them in 2s. We have here to be 1 combined to 1 and 2. For the pairing to be accurate, make sure you pair all the 1 to all the members. Then you come back to 2. Are you okay? So 1 will be given to 3, and 1 will be given to 4. Let's come to 2. 2 will be given to 3. 2 will be given to 4. Let's come to 3. 3 will be given to 4. Now, let's combine them in 3s. Let's combine them in 3s. 1, 2, 3. We have 1, 2, 4. We have 1, 3, 4. Is that all? And we have 2, 3, 4. 2, 3, 4. Is that all? And the set itself. Okay? So superset, the set itself. So you join the set itself to the subset, and that will give you the 10 supersets. Let's count all the possible subsets that we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wow. We have 16 subsets from a mother set with only 4 members. So what will happen if you have a given mother set with 10 members? Assume the subset you are going to get from it. If we have a set defined with 4 members, you have gotten 16 subsets from it. What will be the number of subsets from a set defined with 10 members? Do magic and tell me the figure. Magician. 1024. Hard. Make sure you don't use calculator. Just assume any number of subsets we can get if we have the cardinality of the sets defined to be 10. Say 1024. Wow. Then the 20 will be millions. So when you have a set with 20 members, they are going to get millions. If it is 10 and you are getting 1,000, then 20 will be about 2,000, from above 2,000. Then that's when you are going there, set it. So can you list? Okay. Yes, brother. You said 1024. That will be derived from a set which have 10 members. So if I ask you to list all the 1024 subsets for me, will you be able to? No. But how did you know they are 1024? Since you did not list. Magic. Does magic exist? Does magic exist? You assume, and possibly it can be true or false, right? Okay, so we have different ways that if even you are not listing the members to know. So this one, the number of subsets is 16. You have to list before you know. But if you want to know without listing, then we are going to introduce something called power sets. Power what? Sets. Okay, so let's look at power sets. And it is presented by 2 exponents, n. Power sets. This one determines the number of subsets that we can derive from any given defined set, whether the members contained in that defined set are thousands. Don't worry. The power set will give you the accurate number of subsets you should get from that given set. So let's define the variable n. So where n is, n represents what? The number of members in the set or cardinality of the set. So where n represents number of members in a given set. So we are still on your question, Mr. Magician. We want to know whether the answer is true. So let's use this as, so we have set A being given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements in set A. In this form, they will not ask you to list because you use all your time to do the listing. You will still get it wrong. Why? Some of the subsets you are going to skip some of the subsets. In fact, your combinations will make you sweat. Yes, truly, for you to get that 1024. So let's use the power set to deal with this. We have here to be, so 2 exponent n, where in this set, n is equal to 10. So you are going to substitute n in place of what? 10. So you have 2 exponent 10. There's a time you can use calculator. Just punch 2 exponent 10 for me. 1,000. Okay, let's all clap for our magician here. Very good. So that is the use of the power set. Whenever the set being given to you or defined to you is too large for you to be able to list all the subsets, then you are supposed to use the power set to determine the subset that you are going to have. All right. So quickly, let's look at operations of sets. We are going to talk about intersection, we're also going to talk about union, complement. So that is it. So these are the 3 operations of sets. Let's look at the first one, intersection. So when we described the Venn diagram, we looked at something. When the 2 diagrams overlap each other, which means they have something in common. That is the concept of intersection. When 2 sets have something in common, take that element that are common out, and that gives